pH graphs are a great way that we can take data during a titration and then represent that data in a way that allows us to do the calculations we need, but also understand what's happening in the solution at different times during the reaction. So in order to make one of these graphs, you need to record the pH at different times as certain amounts of your analyte have been added. So the pH measured at the beginning would be just off in the solution we are trying to test in a beaker or flask, and then we add small amounts from our burette, recording the pH throughout. It shows the pH initially and then after each amount. And depending whether we have strong or weak acids and strong or weak bases, we would have a distinctive shape. All of them have some similarities in terms of the shape that are important. And the most important one is the inflection point, or the change in curvation, or the change in concavity right at the equivalence point. That is where we have a really steep part of our graph where we're changing from being curved one way to the other, or changing from one thing being the limiting reactant to the other. We'll start by looking at graphs of strong acids and strong bases. So in this one, we have a strong acid titrated with the strong base, meaning we start with a strong acid solution, we add base to it, we see a big jump here, and then it curves the other way. That middle point is where it goes from curved this direction to the other, or that's our inflection point. Over here, this is a strong base titrated with the strong acid, meaning we start with a base in our beaker and we add acid to it until we get to the point where it neutralizes a pH of 7, same as over here, and eventually the acid becomes excess. Here, the acid is excess while the base is being added and is limiting. The base is excess now that we've used up all of our acid. Here we have limiting base, and then the acid becomes an excess. Both of these have some similarities, and we're going to highlight those down here. Initially, the pH is based only on the solution that is in the flask. So that's either very low for a strong base or very high for a strong acid. The pH changes very slowly initially, because even as I start to neutralize my initial solution, it is still definitely in excess. And remember, to change pH a value of 1, that means you're becoming 10 times more acidic or 10 times more basic. That takes a while before that would happen. There's a rapid change in pH at the equivalence point when our initial excess reactant, the thing in the flask, is neutralized and then replaced with the excess of what we are adding to it. When it's strong with strong, as we highlighted, the equivalence point would be 7. And then once we get to an excess of what we are adding, it will flatten off again. Remember, even though we are adding more and more and more of it, it takes becoming 10 times more concentrated before the pH changes by a whole value of 1. So the graphs themselves tell us what we have more of, what we have less of, at what point that changes. And if I drop down, it tells me the volume at my equivalence point. That allows me to perform my calculations. How much in terms of liters or often milliliters of our analyte has been added. All of these calculations are going to be stoichiometry calculations. The initial pH and the pH at any time along the curve is just based upon the molarity of the thing we have in excess, based upon the moles of it and the liters of our solution. What is important, whether it's strong with strong or strong with weak, as we are adding more, we are changing the volume of our solution. So if we are taking away some acid or adding some acid, if we are changing the pH by doing this reaction, not only are the moles of H plus and OH minus changing, but the volume is also changing, which means we have to account for that when thinking about the molarity to get to the pH. The most common calculation you will do with any and all titrations is use the volume to find the molarity or the amount of the unknown, but we can also be asked about the pH at the beginning, in the middle, after the equivalence point, and sometimes even before. And the calculations you'll be doing with each different type of graph gives you some examples of that to try out.